Okay. Okay, here I've rescaled the y equals x squared graph, so the x interval becomes -1, 3. Okay? So, x interval is now -1, 3. You've got just a little line here to kind of indicate it. This is not the x-axis. The x-axis is still up here. Okay? So here's your x-axis. My question then is, where's the vertex on the rescaled axis? And I should have said the rescaled graph. Or the rescaled set of axes, whatever. Well, vertex is here. It's no longer 0, 0 because you're on the green coordinate system. This is the point 1, 0, right? So, do that in green to show that's on the green set of axes. So on the green set of axes, your graph looks something like this, doesn't it? For here is now -1, here's 1, here's 2, here's 3. The y scale, still you got 4, you got 2, you got 1, you've got 3. Okay? Is that clear? If you do that rescaling, this is the way your graph looks on the new scale. Okay? The graph is no longer y equals x squared. This is your x and this is your y. Y equals x squared would have a vertex here. Be just your basic graph. Okay? Okay. What we've done in the rescaling is we've added one to each of the endpoints, right? Okay? So we've replaced the x interval, -2 to 2, with -1, 3. So we've added one to every x coordinate. Without changing the y coordinates. The new graph let's say represents a function, it's got a formula and it's not x squared anymore, right? Okay? Sorry?
Y equals x squared plus 1?
Is what?
Y equals x squared plus 1?
Close.
Okay.
Got the right idea. But that would be if we moved all the y coordinates up one. You think about it. But yeah, we're gonna bring it out here. It's a good try. Okay? Definitely right idea. Okay, well, what I want to do is I want to make a table. For the rescaled graph. Okay? So when x is -1, what's y? Well, where did it come from? The point -1, whatever y is, came from -2, 4, right? Okay, so the -2, 4 point essentially moved over 1 unit. And we could actually do this. We could go up over here to -2, and we could sketch our graph. Of the x squared function. Okay? And we can understand from what I've done here, replacing the -2, 2 with a -1 to 3, that every one of these points moves over 1 unit to the right. Is this making sense? So that -2, 4 in the new graph becomes -1, 4. And -1, 1. Becomes 0, 1. And so forth. Okay? So when I ask, when x equals -1, well, see, our x value is going to be -1, 0, 1, 2, 3. Okay? Our y values, the x equals -1 point came from the x equals -2 point of the original graph, which had y coordinate 4. So from this picture, just the rule that we followed, we see that this point has to be -1, 4. And 0 comes from -1 over here. Y was 1. So we see that y is going to be 1 here. And if we follow this, we see that the y values are the familiar values for the x squared function. Okay? That make sense? Okay, well, what is this function? I don't expect you necessarily to figure it out right now. Tiffany made a really good attempt. Wasn't quite right, but it was a good start. Okay? I'm going to tell you what it is, and then we'll compare it with the table. It's x minus 1 squared. So this function is x minus 1 squared. We can test this. If x is -1, then what's x minus 1? -2. And if we square that, we get 4. Well, it works. If x is 0, 0 minus 1 is -1. Square that, we get 1. If x is 1, and this is kind of a key point, well, that's a point that makes this 0. And in squaring 0, we get 0. So there's our vertex. And so forth. Now, I'll have an exercise where I ask you to run through this for different, what if we subtract 1? In other words, replace negative 2, 2 with negative 3, 1. Then what's our graph look like? What's our table? And what's the function? Okay? Same process that I've used here. The reason this is important is that we conclude it's a big deal. It shifts the graph of y equals x squared 1 unit in the horizontal direction. That makes sense? And the key is, if we want to shift something 1 unit in the horizontal direction, we've got to replace x with x minus 1. Okay? So a minus here moves you in the positive direction. That's one that's hard for people to get their heads around. I've never explained it this way before. I've never started out the course with the rescaling. Okay? I'm in hopes that people will actually understand the rule and apply it correctly. Okay? The rule is general. If it was x minus 4 squared, what do you think would happen? What would happen to the graph of x squared? It would shift 4 units to the right. The vertex would now be at 4, 0. Okay? It would look just like this, except it would move further to the right. Okay? And all the points of our basic graph would end up in the first quadrant. Of course, the complete graph, you'd have a lot more. Okay? Right. And incidentally, a little terminology that I should use more carefully. This is the basic extended graph. The basic graph of x squared would just be these 6, 7 points, okay? But that's what we've done. We've looked at what happens to each of those points. And I didn't do the 1/2. I'll ask you to do that when you do that, okay? And once you get the complete picture, and once you deal with the fractions. Fair enough? Pretty simple process, and I'm not going to ask you big, tricky numbers. Just get that basic idea down. Okay? Now, this goes on to a little bit of function notation that I want to introduce.